Now let's see how we can visualize data by creating lines and bar graph. First, we need to import the data into Houdini. Here is a CSV file and that I have downloaded from internet, and here we have a sales information. We have the city, postal code, all of this information. Now let's import all of this data into Houdini for visualization. And inside of Houdini, let's create a geometry node and let's dive inside. And to import this CSV file, we have a node called table import node. So let's add this. Let me zoom in. Let's bring up its parameter, and onto the file, let's select a CSV file. And let me pick my selection. I have stored that in my C. Here we have the sales data in CSV. So let's hit accept. And in here, it's showing a warning. We need to define which attributes that we want to import. And in here, we have the city, postal code. So which of these information that we want to import, we can click on this fill attribute info from header. If we click that, it will import all of these attributes from the header. So this first row is called the header, the city, postal code, that is our header. And here, as you can see, we have an attribute named city. And if we take a look at the geometry spreadsheet, and let me unpin this, and here, as you can see, we have all of these attributes imported. We have the city, postal code, profit, and all of the information has been now in Houdini. And when we added a table import node, it will create an A1 points for each of these rows. So now we have 9,000 rows. So let's limit the data import. We don't need that many points. And for that, let's enable the max rows option. And now we are only importing the first 100 entries. And let's maybe lower this down to even more. Let's only import maybe 30 rows. Let me change this to 30. Okay, 5 middle mouse button. Now we only have 30 points, which means we are only importing 30 rows. And we have 11 point attributes with all of these information. And now all of these points are at the origin at the 0, 0. Now let's arrange these points. And I want to lay out these points on to my z-axis. Let me rotate my view. And here I have the z-axis. So let's arrange these points onto this axis. And for that, I'm going to use an attribute warp node. And let's connect this, and let's dive inside the attribute warp node. And for the position, I'm going to use the current point number as a point position. Okay, and I want to set the z position. And for that, let's add a node called set vector component. Set vector component, and that is the value that I want to set, the position value, and which value we want to add. And I want to add the point number. Let's select the point number and let's add this. And onto the vector component, let's bring up its parameter. Here we have the vector component. Right now we are setting the x component. Component 1 means the x, that is the y, that is the z. And I want to set my z component. So let's change this to component 3. And now let's put this into our position now. And now here, as you can see, we are arranging these points onto the z-axis because the point number is an integer value. So now we have 0, 1, 2, 3, all of these points onto the z-axis offsetted by 1 unit. So maybe let's scale them down to bring them closer. And for that, let's multiply our point number by lower value. So let's add a multiply node in here, and let's connect this, and let's multiply by this by some value. And for that, let's promote this second input by middle mouse button on this input, middle mouse button, and promote this parameter. And let me click on this button to expose the connected parameter node. And in here, let's name this. I'm going to name this one to be the scale, and also label this to scale as well. And now we can go back and we can adjust the scale, and here as you can see we can bring closer than 1, and that is because we have a point number is an integer value, so we need to convert this into float. So let's add an integer to float node, integer to float, and connect this. Now we have a float attribute, and we also need to change the input parameter to float as well. Right now it's set to integer. Let's change this to float. Now let's go back, and now I can bring values lower than 1 because now we have a float attribute. Okay, by adjusting the scale I can bring all of these points closer. Let's change this value to 0.5 for now. We can adjust this later onto our need. And now let's copy some boxes to create a bar graph, and for that I am going to create a box node in here. That is our lovely box, and let's add a copy to points node, and let's copy our box geometry onto these points. Okay, now let's go into the box and adjust its Z size to control its depth. So let me lower this down right about here, and let's also adjust its X size as well. So let's lower down its X size. That is looking good. And now let's use the information that we have imported to set the scale of each of these boxes. And let me click on this attribute warp node, and maybe let's rename this. We're going to call this one set Z size, or maybe we can say set Z length. Okay, that is good. Now let's click on this node and go into the geometry spreadsheet, and here we have these attribute. Let's see which attribute we can use. Let's use the profit ratio to set the scaling of our boxes. Okay, and for that we can use the p scale to control the boxes size because we are using the copy to points node. And for that I'm going to create another attribute warp node in here, attribute warp. Let's connect this, and I'm going to rename this one set p scale. And now let's dive inside this attribute warp node, and in here let's import our profit ratio attribute by using a bind node. Into the bind let's type the name, and the name, it has to be case sensitive, so the p is capital. So let's type P capital and profit ratio, and the R is in capital. Okay, now we have profit ratio imported. Now let's set this as an p scale attribute. So we can say bind export, and we can export this attribute as an p scale. So let's rename this one to p scale, and let's connect this in here. And let's go and see, and here as you can see, because we have a profit ratio and a very large value, so we have a very large box sizes. So let's dive inside, and in here let's control the scale by multiplying a value. So let's add a multiply, and let's expose this second parameter, middle mouse button promote parameter, and let's click on this to expose this parameter node, and I'm going to rename this scale, both of them to be scale. Let's go back, and in here we can adjust the scale. Okay, and now here as you can see, some of the boxes has been inverted, and that is because our profit ratio is go in minus values as well. So let's get rid of this minus sign from the profit ratio, and for that let's add an absolute node in here, abs absolute, so that will take care of the minus values and we will only get a positive values. Okay, so now we do not have an inverting issue. And now let's go back and arrange our box so that it will perfectly sit onto the floor. and right now it's not sitting onto the floor. That is because our box is actually not onto the floor, it's in the center of the grid. And for that, let's add a match size node in here and connect this. And onto the match size, I'm going to change the justify y to minimum. Now we have our box perfectly sitting onto the floor. Now let's view the result of the copy to points node. And now here as you can see, we have these sitting onto the floor accurately. Let's go into the set scale, and here we can adjust the scale. Okay, and here as you can see, because p scale is a uniform scale value, it set the overall scale. So that is why we do not getting an accurate scale value. But I want the scale to be adjusted onto the y-axis, so we can use another attribute that is called scale. If we enable the help of the copy to points node, and if we go, and we should see some attributes, copy and instancing, not here, instancing point attributes. Let's click on it, and these are the attributes that copy to point node understand. And right now we are using the p scale, which is a float, and it's a uniform scale. And we also have an attribute called scale, which is a vector, and it's a non-uniform scale. So let's use this attribute to set our scale. So let me dive inside in here, and let's delete this p scale, we don't need that. And in here, let's add another bind export node, and for this one we are going to set our scale, and that is a vector. So let's change this to 3 float vector. Okay, and I only want to set my y component, and for that let's add a set vector component node in here, or maybe we can change this to float to vector. Okay, and let's use the y, that is the x, y, and z. So let's use this one to set our y scale, and let's connect this into our scale. Let's go in here, and onto the component 1, let's change this to 1, x to 1, and z to 1 as well. So now we are only scaling our y size, and we are not adjusting x and z size. That is good. Let's go back onto the set scale. Now I can adjust these values to make my graph bigger or smaller. Okay, and now I can go back onto the z length to adjust my spreading of the graphs. I can bring my graph closer, or I can expand the graph, and I can also go back onto the box and I can adjust its z size. Okay, I can also make them thicker by adjusting this size, the x size, and that is fine. And I can go back onto the import node. I can import more of these rows or lower of them. Okay, let's change this to 30 as well. And now let's add a text in here to show that what of these graph is actually corresponding. And for that, if we go into the table import and take a look, and here we have a data for the city, we have the profit ratio, quantity. Let's see which one we want to show. And I want to show this information, the subcategory that will show the graph of what of these things that are being sales more. Okay, so let's add a font in here, and I'm going to use this one where we have set at the length. Okay, so in here we can create a font, and onto the font we can import this information to visualize. Okay, and first we need to add a copy to points node, and I want to copy the font onto these points. Let's use this one, and by using this method we can't import these attributes Okay, so to import this information, this subcategory information onto these fonts separately, we need to use the loops. And for that, let's use a for each point loop, because we are working with points, as you can see. So let's connect this into here. Now this loop will run over all of these points one by one, so which means now we can connect this into our for each begin and this one at the end. Okay, so now we will have access to these points. So let's go into the font and let's add a expression to read our point attribute. This is our subcategory attribute. Let me go back, subcategory attribute. Let me pin this. So now whenever we select another node, this geometry spreadsheet will always going to be pinned to this node. Okay, so onto the font, let's use the point function to import this subcategory attribute. And for that, let me bring up my help by going on to the help and contents, and in here let's search our attribute. And because it is a string subcategory, it's a string attribute, so we need to use the point s function, which is used to fetch the point string attribute. Here we have the points. Let me expression function, let's click on it, point expression function. Okay, we have points and a vex function, and we have an expression function. And for using this in font, we need to use the expression function. Okay, so keep that in mind. So here we have the syntax of this node, and here we have the example. So we need to type the function name. And for the font node to actually evaluate the function, we need to type this in the backtick sign. So that backtick sign, which that key is also called the tilde key, that is above the tab key. Okay, so let's add this, and in here let's type the function name, and that is called the points. And in the braces, we need to define the path from where we want to access the information. And right now it's saying that obj and go1, and we can replace this obj as well as go1 by two dots. So we can say dot dot, so which means the obj, that is the obj, and go1. Okay, and after that we can add a forward slash, and we can type the name of the node. And I want to fetch the attribute from this node. Let me zoom in. This one, for each begin 1. So let's type the name in here. That is called for each underscore begin 1. Okay, that is the node, and that must be written in double quotation because that is a string. Okay, so let's add double quotation at the start, at the end, as well as at the start in here as well. And after that, we need to separate this by comma, and we need the point number because we are working in loops. So point number will always be 0. So let's add a point number 0, and we need the attribute name. The attribute name, it should be written in quotation as well. So let's add a comma and the quotation, and the attribute that we have is called the subcategory. So capital S. Okay, and now let's close the braces and let's go back, and with the result, let me close the help and also close the font parameter. Let's go into our scene view, and now we have the information imported. Let's rotate our font, go into the font, onto the rotation. Let's rotate it around Y, change this to -90 degree, and also let's lower down the scale, value, keep lowering this down 0.7 maybe, and let's change the font as well, change this to Arial bold. Okay, and maybe we need to increase the size. Let's go into the size length. Let's continue increasing this size value. I'm setting this to all the way up to 1. Let's lower down the font size. The font is still bigger. Okay, now I can start to see all of them. We have paper, label, binders, all of them. Let's add a merge node in here. Let's merge this with that. Okay, let's go into the font, And onto the alignment, let's change this to top to adjust the alignments. Maybe let's adjust its length a bit more, and let's go into the box size and adjust its Z size. Okay. Now we have the data imported and it's all procedural. I can import more of these rows or less of these rows. Okay. And our setup will work perfectly fine. And now let's visualize some other information in here. And for this time, let's visualize this sale information. Okay. And I'm going to visualize the sale information on top of this graph. Okay. Let me duplicate all of this setup by selecting all of them, Alt and drag to duplicate all of them. Okay. And for this time, first, let's bring these points up where we have set at the length and we have set at the Y scale to adjust the scale. Okay. So let's copy this node as well where we are set at the P scale. Let's add this. And for this one, I'm going to connect this at here. Okay. And now let's adjust this point Y position according to our profit ratio. So let's dive inside, and in here, let me remove all of this scale. We don't need that. And we also don't need the float to vector. Let's add an set vector component node in here. Set vector component. And I want to set my position vector component. And that is the value that I want to set. Connect this one in here, that is our value, and I want to set my Y component, so let's change this to component 2 and let's connect this into our position. And now we have a Y offset. Okay, let's go back and we can link this parameter. So if we were to adjust the Y size in here, so that we can control both of them. And for that, let's link this parameter. So that is our master. Right click, copy this parameter, go in here and paste relative reference. Okay. So whenever we adjust the scale in here, let me view the result. Whenever I adjust my scale in here, I will also going to adjust my Y position onto this side as well. Okay, which is good. And now onto the font node, let's import our attribute, sale attribute. And if we go into the geometry spreadsheet and if you take a look at the sale, so the sale is an if integer attribute, so which means we need to use the point function and not the point s function. So if we go into the help and onto the contents, let's type our function name that is called point. First we have the vex function, but we are going to use the expression function. Okay, point expression function. Here we have the syntax as always, surface node, and we have the point number, the attribute, and we also need to define the index because we can import the vector. So vector has 3 index, 0, 1 and 2. Integer has only 1 index, so the index value should be 0. Let's see how we can do that. So we need to actually onto the point, let's remove the s and for each begin 2, which is good. Here we have for each begin 2 and point, and we have the point number which is 0 because we are working with loops, so point number will always be 0. And the attribute that I want to import is called the sale. So in here let's type the attribute name sale, and onto the index should be 0 since we only have an a1 index value. It's not a vector, but it's a single integer value. Okay, so now let's go back and view the result at the merge, and it's not being imported, and let's see why. What's the name of the attribute? That is called the sales and not the sale. So we forgot to add s in here. Let's add sales. Okay, so now we have the sales information imported. Let's merge both of them together. we have an emerge node. Let's connect this one into the merge as well. Okay, and we need to go into the font and change the alignment to bottom. Okay, so now we have these sales as well as this. What are these things that are being sold? That's how you can import the data and generate graph, and it's all procedural. I can go into the table import. I can just import more of these rows and our setup will adopt. Okay, I can adjust my graph scale by going on to the set scale. Okay, and all of this will work fine.